Section 7.1 is dealing with operations with functions. If we wanted to evaluate f of 3, that means we're going to plug in 3 into the f function. So wherever we see x, what are we going to plug in? 3. So 3 times 3 plus 4, that's 9 plus 4 is 13. Number 2, the g of negative 5. So that means we are going to plug in negative 5 into the g function. So wherever we see x, what are we going to plug in? Negative 5. So that's negative 5 squared minus 5. Negative 5 squared is a positive 25. Minus 5 is 20. And number 3, h of x plus 2. So anywhere we see x, we are going to plug in h plus 2 into the h function. So the h function is f minus square root of 5 minus x. So I am going to plug in 5 minus, and what am I going to plug in for x? X plus 2. And I have to enclose that in parentheses. Then I would distribute the negative and get negative x minus 2. Combine like terms, 5 minus 2 is 3. So that's 3 minus square root of 3 minus x. Now, in example 1, given f of x is equal to x squared minus 4 and g of x is equal to 2x plus 1. We want to find f plus g of x. F plus g of x means we are going to evaluate f of x plus g of x. F of x is x squared minus 4 plus g of x is 2x plus 1. So we're going to add these two functions together. And when you add, remember you put it in descending order, which is the same thing as standard form, and combine like terms if you can. So that's x squared plus 2x. Negative 4 plus 1 is a negative 3. So if f plus g of x means f of x plus g of x, what do you think f minus g of x means? It means f of x minus g of x. And f of x is x squared minus 4 minus g of x is 2x plus 1. But because we are subtracting that whole thing, we have to enclose that in parentheses. And then we would distribute the negative out. Combine like terms. And put it in descending order. Example 2, you're given f of x is equal to x squared plus 7x plus 12, and g of x is equal to 3x minus 4. So f times g of x, what do you think that means? F of x times g of x. And f of x is x squared plus 7x plus 12. And then we're going to have to multiply that times g of x. And g of x is 3x minus 4. So what are we going to have to do here? Put everything in parentheses. And then we're going to have to multiply. And we know how to multiply a trinomial times a binomial. So when we distribute, we get 3x to the third power minus 4x squared plus 21x squared minus 28x plus 36x minus 48. Check to make sure I didn't make any mistakes. We're going to, again, combine like terms and put in descending order. So the 3x cubed comes first. Negative 4x squared and a positive 21x squared is positive 17x squared. Negative 28 and a positive 36 is a positive what? 8x. And I don't have anything to bring down the 48 with, so I'll bring down 48. Now we need to find f over g of x. So that means f of x over g of x. And what is your f of x? X squared plus 7x plus 12. And your g of x is 3x minus 4. Now, so many people last period were like, oh, do I do the synthetic division now? No, we're just practicing putting it in fraction form. Now, here's the difference. If you had a fraction, remember, what can you not have in the denominator? Ever, 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 ever. Can you never, 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 never have what? A what? You could have a negative in the denominator, but what? I'm sorry, did I say exponent? I'm sorry, I said I meant denominator. What can you not have in the denominator? What can you not have in the denominator and you get an undefined? If you put in the calculator, 0. You cannot have 0 in the denominator. Remember? You cannot have 0 in the denominator. If you ever get 0 in the denominator, that is undefined. Remember in chapter 6 when they were giving you the very first part when you were simplifying polynomials and they always said in the direction simplify, assume no variables, no denominators have 0 or something of that nature. That's what they were saying. Okay, so do I have a variable in the denominator right now? Yes. So I have a possibility that I could get 0 in that denominator. So to find out what value would x be, that if I multiplied it by 3 and then subtracted by 4, what would give me a 0 in the denominator? To find that out, take it out of the denominator and put it equal to 0. That's how you find out. So add 4. So 3x is equal to 4. Divide by 3. So x is equal to 4/3. What that means, if I put 4/3 right here, I multiplied it by 3, and then I subtracted 4, what would I get? 0. A 0. And I cannot have 0 in the denominator. So I have to state a restriction. My restriction is x cannot equal 4/3. So anytime you have a variable in the denominator, you have to go and set a restriction. Okay, y'all try to do these two examples on your own. Okay, f times g of x means f of x times g of x, so check your answer. And then f over g of x means f of x divided by g of x. And then don't forget the restriction. Now this was an easy restriction. You could look at this and say, oh, if x was -4, I'd get a 0 in the denominator, and I cannot have a 0 in the denominator. Therefore, x cannot equal -4. So that's stating the restriction. Any questions on that one? Composition of functions, or where the results of one function are used to evaluate a second function. Example 3, f of x is equal to 2a minus 5 and g of x is equal to 4a. We need to find FOG, that spells fog, fog of x. What fog of x means? It means we are going to evaluate f of g of x. it gets a little bit more complicated. We've got f parentheses g of x. The way we read this is read f of g of x. That is the way you read that. So it can be given to you fog of x, or it can be given to you f of g of x. They mean the same thing. So think of when you're simplifying, when you have more than one set of parentheses, you always want to work inside and then work your way out. So what we want to do is we want to look at the g of x. I'm going to highlight. That might help. We're going to do g of x. And what is g of x? 4a. So what we are going to do is we are going to replace g of x with 4a. So bring down the f, parentheses, and we are going to replace g of x with 4a. Then, what we're going to do is we are going to replace 4a with a, with a in the f function. So right here. So in the f function, we're going to copy down the f function, but in the variable, what are we replacing that a with? 4a. Very good. So that's 2 times 4a minus 5. So that's 8a minus 10. It's kind of like, think of two sets of substitution in one problem. Now let's do the GOF, which is GOF of x. GOF of x, how would we write that? That would be written G of f of x. So once again, we want to work inside. So we're going to copy down the G first. And what are we going to replace f of x with? 2a minus 5. That's right. And then, wherever we see the variable in the g function, what are we going to replace?
A with 2x minus 5.
We're going to replace a with 2x minus 5. Yes. Did you have a question, Marcus?
No,
Yes.
When you put G, did you just imply that the 4 was a A of the 4A was already in parentheses?
Right here?
Yes.
Okay, just bring down the G, and all I'm going to do right here is replace the f of x with this function.
No, I was talking about the G when it goes down and you put that.
Yes, the 4. Yes. I replaced the G with this, and I put the 4, and then the A gets replaced with that.
And how did you get
8?
A out and put 2a minus 5.
So it's already implied that the A is a part of the 2A?
4 is still there.
I thought the 2a minus 5 came from f of x.
It did.
But then where did the a go on the
The
third
A's
step?
will replace it.
I substituted right here.
She replaced the A and
Hold on. Too many questions and y'all are all confused. What is f of x? What am I replacing f of x with? 2a minus 5. So now I'm going to copy down the g function. What is the g function? 4a. And then I replace this. This now replaces my variable. So I bring that 4 down, and this replaces my variable. This goes for right there.
So always take the constant of the function.
How did you get, you lost me when you got like the F and then how did you get that from off? That's what I don't know.
I have no idea what you're asking me. Where?
Like when you, like where the
The O
equation
is
is,
up.
how did you get
Which
that?
equation? I have multiple equations up here. F of G, F O.
That one. How did you get that and then like you put the equal to and then you did F, G and then like little x? I don't understand.
This means the same thing. That means F of G of X. hopefully y'all will get it. We're gonna do more than just one problem. Okay, do you understand that part, Caitlin? Do you understand so far everything that I've done? You understand where I got the f and the g of x?
I get
Okay.
it. Okay.
Okay. Riley, leave the window blinds alone. Have you done this? Now, guys, what you need to do before you start this section, the first part was pretty easy. Here's where it gets a little bit more complicated. How many of you go back over your examples and work your examples before you start your homework? Maybe y'all should start doing that. Especially these examples. What I would do is I would get a clean sheet of paper and I would cover up my work and I would work the problem and I would do one line at a time and then slide it down to see if I'm doing it right. So with your notes helping you to work the problem. It might take 3 or 4 times before it clicks. Okay? But that's what you have to do. Jacob, pay attention. This is not an easy subject, and when you're sleeping, you miss stuff. Okay, y'all finish that. So that's 9x squared plus 24x plus 16 minus 5. Does everybody understand where they got the 24x? Good. So that's 9x squared plus 24x plus 11. Y'all want to try E by yourself?
Yeah.
Try E by yourself. Okay, look, right now we have g of 5 square root of 5 minus x. So into the g function, wherever we see x, we're going to plug in 5 minus x. Square root of 5 minus x. Right in here. So what replaces x? Square root of 5 minus x. So that's square root of 5 minus x, and then we don't forget we have to square it, and then minus 5. Do y'all agree with that? Now, when you square a square root, what's inside just falls out. So this really looks bad, but it's not that hard. It's just 5 minus x. Minus 5. Your 5's go away, so what's your answer? Negative x. Very good. And that is your assignment.